My name is Christian von Koenigsegg. For half of my life, I've been on the quest to be a leader in the hypercar industry, utilizing Swedish design combined with visionary technical solutions.
After 3 months or more than 3 months preparing the crash car that we are sending to the test facility, it's really hard to see how the car is slowly being destroyed, hammer it, over torquing it, and then finally crashing it against the wall. It's painful. It's painful to watch.
For the US, for example, we have to crash test our cars even without belts and install what they call smart airbags that are able to sense if it's a small or a big person sitting in the car, where they're sitting on the seat, if they have a belt or not, which angle we're impacting the car from, and then we should tune the deployment, the strength and the volume of the airbags according to those set parameters. And in order to get the data to be able to do that and to program these systems, we have to crash our cars from every conceivable angle at different speeds, from the side, from the rear, from the front, offset, corner. Even considering a bicycle driving into the car or someone bashing away with a hammer on the car and not deploy the airbags when they shouldn't be deployed and deploy them when we should.
Sorry.
It's stressful.
Yeah, it's stressful. It's quite stressful because time schedule is tight, because everybody wants their supercar as soon as possible. So regular manufacturer can crash 16 cars, it's no problem. But for us, 16 cars is almost our annual production. So we cannot crash 1 year production in one wall. So it's very expensive, fairly long.
One of the methodologies we use to save basically money for this process is that we designed our carbon fiber monocoque to withstand all these different types of crash tests without being destroyed. We destroy the bodywork on the outside, subframes, crash members and so on, but not the actual integral and most expensive part of the car. So the same monocoque chassis and the same car, if you will, is being used basically for all of these tests. And this is very unusual. If you take a large car manufacturer, it's much cheaper for them to take a car out of the development, their production line, crash it, throw it away, take another one. But in our case, it's completely different. It's cheaper to rebuild and repair and keep on smashing the same car. That's of course in a way more difficult because it needs to take multiple hits, but we designed for that, so it works and it saves us both time and money and resources. For this program we bought a supercomputer that we have in our basement where we can crash simulate carbon fiber structures, which is very unusual. So we have some specialists dedicated to that work here at Koenigsegg that actually have been part of developing the programs to be able to crash simulate carbon fiber cars. This means we can reduce somewhat the risk when we're actually crashing the cars, that we know the results, and every physical test we do, we correlate back to the simulation to make sure it correlates so you have even bigger chance to hit it spot on for the next test. It's really an exciting process in a way, because we want to make our cars really safe, and we get that verified over and over again through this process. But at the same time, a bit painful seeing our babies being crunched and crumbled in this way. So.
We built the car here in Ängelholm, and then we sent the car in our facilities near Barcelona. And then it's a logistic cost also, quite a long process. We send the car there. We are able to be in front of the test while they are doing the test, but we are not able to brake or be inside the car while braking or prepare the car for the crash test. We give them the car and they prepare it and they crash it. We're always only there to assist them and give them information where to put the sensors and stuff like that, but nothing else.